Hello and welcome to our discussion today on the cell cycle. The cell cycle. The cell cycle is also known as the cell division cycle. So there is a cycle of events that the cell must go through in order for it to divide. So the objective of today's discussion is to look at the major events that happen during the cell cycle holistically. Then in the subsequent videos or in the next lectures, we will take every in each stage and every in each phase of the cell cycle and discuss it in the due depth that it deserves. Okay, so today we will talk about the cell division cycle, and before that, let's make it clear as to what are the causes for the cell division. What leads the cell to divide in terms of what is the purpose? What is the purpose that the cell serves when it divides? The first purpose is natural growth and development. So you look at a baby that is just born and then you compare it into the next milestones that happen in the life of the child in terms of growth and development. You see that the cells have obviously divided, and the cells grew, and this individual matured and developed, and cell division played a very important pivotal role in the natural growth and development of the organism. So the first purpose is to manifest the growth and development of the organism. That's why we have cell cycle and cell division cycle. The second cause is for healing and regeneration. So when there is an injury, whether it's a superficial injury or an injury in the underlying tissue, what happens is we have healing by regeneration in cases where the injury is not, it did not elicit inflammation. What happens is the nearby cells in the tissue would start to proliferate through cell division, and they will start to grow and make up for the cells that were lost in the injury. So the second cause is for healing and regeneration. The last very important purpose that the cell division serves is rather pathological. So the first two purposes we talked about, the cell division that serves the purposes of growth and development, and cell division that serves the purposes of healing and regeneration, these are physiological purposes. What about tumor growth? What about cancer, invasion, and metastasis? Obviously, that takes place through aberrations that lead to uncontrollable cell division. There is uncontrollable signs and signals that lead the cell to grow and divide uncontrollably, and also there is a defect or a mutation in the proteins, the enzymes that regulate cell death when these aberrations in cell division happen. So we will talk about that. So what we need to talk about today in the cell cycle, the first thing is that the cell cycle is divided into stages and phases. So the phases are miniatures and the stage is the big stage. So each stage is comprised of miniature phases. And we have two stages. The first stage is the interphase stage. The interphase stage. The first stage is the interphase stage. And it's comprised of the G1 phase, the S phase, and the G2 phase. So the first stage is the interphase stage, and it's comprised of the G1, the S, and the G2 phases. The second stage is the M or the mitosis stage, and it's comprised obviously of these prophase, prometaphase, metaphase, anaphase, telophase, and cytokinesis. So these little phases give us the big stage. You need to know that there are two stages. The first stage is the interphase stage. They are in order. The first stage that comes in order for cell division, it's the interphase stage. And it is comprised of the G1, the S, and the G2 phases. While the second stage is the M stage or the mitosis stage, and it's comprised of these little miniature phases, which are obviously subsequent. So you have prophase, prometaphase, metaphase, anaphase, telophase, and cytokinesis. That's the very first point you need to know, and we will go through that. You also need to know that in addition to having to know the causes or the purposes that the cells serve when they divide, when they enter the cell cycle or the cell division cycle. We talked about how the cell division cycle is important for growth and development, it's important for the healing and regeneration, and it's also important for the pathological tumor invasion and tumor metastasis. So what you also need to know is that what are the tissues and what are the cells? You know, certain cells are constantly dividing. Other cells, they divide when they need to, and other cells are terminally differentiated. They never divide, no matter what. So injury to these tissues will never heal by regeneration, because that is a type of a tissue that will never divide. That is a tissue that developed and reached a terminal stage. It will never divide again. This is very important for you to understand. So the first type of cells that are constantly circulating in the cell cycle, they never rest. They never rest. They're always circulating in the cell cycle. These are called the labile cells, which come from labile tissue. An example for that would be cells of the gastrointestinal system, such as the squamous epithelia and the ciliated columnar epithelia in the esophagus. You have in the mouth, in the oral mucosa, you have squamous epithelia, while in the esophagus you have your ciliated epithelia, and you have in the lymph nodes what is known as cuboidal epithelium. And these cuboidal cells and these three types of cells, they are labile cells. So they never stop. They just keep going through the cell cycle. These are labile cells or labile tissues. Then you have cells that are they are known as quiescent cells. So they enter the G0 phase. So in the G0 phase, they remain in the G0 phase, but once there is need for them to divide, they will divide. And these are obviously the cells of our solid organs, like the liver. The liver has incredible capacity for regeneration. So when you resect a section of the liver can obviously differentiate and regenerate by driving their cells. So the signal of the resection and that missing part of the liver will drive the liver to proliferate, enter the cell cycle, and continue to divide to make up for that lost part. So these are, and you have the pancreas and all the solid tissue, all the solid organs, the pancreas, the liver, and so on. They are known as quiescent, so they are sleeping. But when they need to divide, they will wake up and they will start dividing must there be a need for them to divide, they will enter the cell cycle. And the last but not least, you have the last type of cells, and these are the terminally divided cells. They never divide no matter what. And these are the cells of the cardiac, these are the cardiac myocytes and the neurons of your nervous system, and the skeletal cells. So these are cells that are in the G0 forever. And then you have cells that are in the G0, but they can enter the cell cycle when needed. And then you have cells that never go to the G0 phase. They are constantly dividing. So the last thing that you need to know for today is that there are points known as restriction points and checkpoints. The restriction point is different from the checkpoint, is that it is the rate determining step for the cell cycle. So it takes the most, so going through that point, going through the restriction point, how fast can a cell pass through the restriction point will dictate how fast the process of cell division will take place. If you are asked on the exam, what is the restriction, what is the rate determining, what is the rate limiting step for the cell division, it is the restriction point. Where is it found? It is found between the G1 and the S phase. So between the G1 and the S phase, we have two checkpoints. And mind you, a checkpoint and a restriction point are not the same. So a restriction point could be a checkpoint, but a checkpoint is not necessarily a restriction point. So a restriction point is a checkpoint, but a checkpoint isn't necessarily a restriction point. So we have only one restriction point, and that is, it's a point between the G1 and the S phase. And once the cell, it's called a restriction point because once the cell passes that point, it is now crossing the bridge. It cannot make a U-turn. The cell must go on into dividing. So that cell will be a dividing cell if and only if it passed through the restriction point. Okay, then we have a checkpoint. In a checkpoint, obviously, we check for certain things depending on where are we, because we have how many checkpoints? We have two checkpoints. With the restriction point, there are three, but for now we're gonna name a restriction point is different from a checkpoint. So the first checkpoint will be also right after the restriction point. So right before we go into the S phase where we double the DNA, we first check for this DNA that is about to be duplicated. Is it damaged? Because we don't want to double a damaged DNA. So we first screen and ensure that this DNA that we are about to duplicate is in fact healthy and not damaged. Then in the other checkpoint, we check for it's the stage that is right before mitosis. It's between the G2 and the M stage. And here we check for is there any damaged DNA or any DNA that was not successfully doubled. So let's go through the stages of the cell cycle, and it will make sense as we go through. Okay, so we said the first phase is called the G1 phase, and it is part of the interphase. And the interphase takes about 90% of the entire cell division process. So the time the cell cycle spends in the interphase is actually 90% of the time that it spends in the entire cell division. That is very important for you to know, that the cells spend 90% of the time in the cell division cycle. The cell spends 90% of the time spent in the cell cycle only in the interphase stage, and that is the G1 stage, the S stage, and the G2 stage. Okay, so now let's look at what happens. So a cell that has already finished dividing, we said we have three types of tissues. Cells that successfully divided and will re-enter the cell cycle again. So that's a labile cell. That's a labile cell. That's a labile cell. Or we have a cell that is in the G0 or quiescent phase, quiescence or quiescence phase, and now that cell needs to divide again. Whereas senescent cells, like terminally dividing cells that have divided terminally and they will never re-divide again, these are, like we said, the neurons and the skeletal muscles and the cardiac myocytes. What happens is you will have the first stage is the G1 stage. What happens in the G1 stage is we prepare the cell for the restriction point. And what happens is there will be centromere duplication and growth in mass. So there will be growth in mass of the cell. We double the cytoplasm, we double the organelles, and we double everything that is needed in cell division. Once the cell has now reached the restriction point, which is the first checkpoint, the checkpoint is the restriction point, and the restriction point is the checkpoint. But not every point is a restriction point. Not every point is a restriction point. Not every checkpoint is a restriction point, but the restriction point is a checkpoint. So this restriction point happens to be the first checkpoint where the cell is now checked that it is either a quiescent cell that needs to divide due to there are needs, physiological needs for the cell to divide, or this is a labile cell that must keep on dividing. Then the cell will now pass the restriction point, and now there will be the first checkpoint, and that is the checkpoint between the G1 and the S phase. Check for damaged DNA, check for DNA damage, and this is the first, this is the second checkpoint. So now if you are asked, what is the checkpoint in which the DNA is screened for damage before division, that before DNA duplication, that will be the checkpoint between the G1 and the S phase. Okay, so now the checkpoint has passed, we have checked the cell that all the DNA that must be replicated, the DNA that must be duplicated is actually healthy and is not damaged. The cell will enter the S phase. When the cell has entered the S phase, there will be chromosomal duplication. And when there is chromosomal duplication, we have successfully duplicated the DNA. We now enter the G2 phase. So between the S and the G2 phase, there is no checkpoint. The checkpoint is rather between the G2 and the M phases, between the G2 and the beginning of the mitosis stage, between the G2 phase and the beginning of the mitosis stage. And what happens is, although we have finished duplicating the DNA, we now, in this checkpoint, we check for whether all the DNA has been duplicated successfully. So if you realize that the checkpoint is pretty much not entirely restricted to or exclusively concerned with DNA, it also checks for other organelles and things, but it is majorly concerned with DNA. So the checkpoint before entering the S phase, we actually check for whether or not the DNA that is about to be duplicated is healthy and undamaged or not. If the DNA is damaged, that cell will commit apoptosis, and until that DNA is repaired, it will never enter the S phase and will never cross that checkpoint. The second checkpoint, we also check for what happened to that DNA. It obviously doubled. So a checkpoint before the S phase and a checkpoint before entering mitosis. So here we have checked for whether or not the DNA that is about to be duplicated is damaged, and then we check for this DNA that was successfully duplicated. Was it actually duplicated entirely, or are there any DNA that was mistakenly damaged following the stage of the S phase? So now we will see if there's oxidative stress, if there's any form of injury that causes the DNA to be damaged. If not, then the cell will enter mitosis, where it will go through prophase, prometaphase, metaphase, anaphase, telophase, and cytokinesis. Then after that, the cells will divide after cytokinesis. After cytokinesis, the cells will divide, and now depending on what we're dealing with, are we dealing with a quiescent cell, it will enter the G0 phase, or labile cell will continue to divide again, or terminally dividing cells, they will remain as senescent cells. So you can repeat the video and look at the cell cycle again. I will bring you a little bit closer to our illustration to see more carefully. So what we have here, we have a cell that is about to enter the G1 phase. That cell could either be a quiescent cell, like those cells which are solid organ cells, like our liver cells, or maybe labile cells that are continually dividing. So they will enter the G1 phase. After entering the G1 phase, they will go through the first checkpoint, which is the restriction point. And the restriction point, we make sure that that cell is actually allowed to divide, and that cell needs to divide, i.e. that cell is a labile tissue cell or a quiescent cell that was triggered to successfully enter the cell cycle, and there will be growth in mass of the cell due to the doubling of the organelles and so on. After that, we will enter the first checkpoint, or maybe the second checkpoint, because we counted the restriction point as the first checkpoint. And in the first checkpoint, from the name of the checkpoint, it is called the G1S checkpoint. And we know that in the S phase, we double the DNA. So here we screen and check for damaged DNA. We don't want to double chromosomes that are damaged. We don't want to duplicate chromosomes that are damaged. Then once the cell enters the S phase, the chromosomes are doubled and the DNA is doubled, and then we will enter the G2 phase without going through any checkpoint. This is very important. Between the S and the G2, there is no checkpoint. They ask about this on the exam all the time. And then we have between the G2 phase and the mitosis stage, we have a checkpoint known as the G2M checkpoint. And what happens is we check for damaged or unduplicated DNA. We check for damaged or unduplicated DNA. Once we ensured that the DNA that was doubled in the S phase and now the cell has entered the G2 phase, before it enters mitosis and divide, we want to ensure that the DNA that is about to divide in these cells is actually DNA that is not damaged. Then the cell will go through the prophase, the prometaphase, the metaphase, the anaphase, the telophase, the cytokinesis, and mitosis, and then cytokinesis, the cell will divide and we will have successful cell division, and then we will again enter either the cell cycle if we are labile, or go to the G0 phase, remain there and wait for signals if we want to divide again. Okay, so I will leave for you. Okay, you can now just take a good look at this humble diagram, and we hope that this made good sense. Thank you very much, and see you in our next video.